Q19. If we have a string containing 1,000,000 zeros, and then we have 3 different patterns, if we use brute force string search algorithm to search for these patterns, how many comparisons are we going to perform? I'll give you maybe 2 minutes to figure out for question A, because if you can do that, the other two, I think it shouldn't be a problem. So spend 2 minutes on question A, find the exact number of comparisons that you will need to perform for a brute force algorithm, string search algorithm, finding the pattern in a string containing 1,000,000 zeros. Then I'll quickly demonstrate this and show you the answer. If you get an idea or if you have a solution, feel free to share in the chat window. And otherwise, we'll be going through it together. I think we get 2 different values from the chat window. One is 2,000,000 minus 5, and the second one is, I think that's 2,000,000 minus 10. But let's maybe look at it together. Our pattern is 0, 1, 0, 0, 0, 1. So we place that at the very beginning of the pattern. And what we are going to do first is we're going to have a comparison here on the first character, which obviously that's a match. So we continue with the second character, and this gives us a mismatch. So what we're going to do is we're going to have the pattern move to the right for just one single position. And after moving the pattern, we again start from the beginning. So 2 comparisons. The first one gives us a match, the second one gives us a mismatch. And after finding the mismatch, I think we move the pattern again. I think it should be fairly clear in this case that every time after moving the pattern, we can have 2 comparisons. Because the original string contains all zeros, so no matter where we place our pattern, we are only going to have we're going to have 2 comparisons until we find a mismatch. So now the last possible placement for the pattern should be 0, 1, 0, 0, 0, 1, and this will give us the last 2 comparisons. And I think now the only thing we left is we want to find out how many possible placements do we have for the pattern. Of course, the first one is here, and the last, where did it go? The last one is here. And this is the second possible placement. This is the third possible placement. And if you want to find out how many possible placements in total, I think maybe you can look at the first 0 in the pattern. The first 0 can be aligned with the first 0 in the string, can be aligned with the second 0 in the string, can be aligned with the third 0 in the string, and all the other zeros until this 0. We will have no chance aligning this first 0 in the pattern with the last 5 digits in the string. So how many possible placements? I think we have 1,000,000 minus 5 possible placements. And every time when we put a pattern at a position, we're going to have 2 possible, 2 character comparisons. So this will give us 1,000,000 minus 5 times 2 as the total number of comparisons we're going to make. And just quickly answer a question in the chat window. If we find a match already, are we going to continue? And I think the answer is no, we're not going to continue. For example, if 0, 0, 0 is the pattern we are going to look for in this case, we're just going to have 3 comparisons. Because the idea of string search algorithm is that we want to know whether we can find this pattern in the string. If yes, then we just return the first occurrence. And in this case, if we can find the string 000 in the beginning, then we're just going to have 3 comparisons and then return 0, indicating that a match can be found starting from index 0. All right, that's question 19. And I suggest that you spend some time looking at question 20 during the weekend. It's not super straightforward, and it's not challenging at all. The main idea is that we use the similar idea used here in question 19, and we are asked to construct a worst case scenario for the brute force string search method. And we want to find out what's the maximum number of comparisons we can make. And after reading the solution, I think you will understand what does it do. Question from the chat window: why 10 to the power of 6? We only compare the first and second element, then move to the next position. So 10 to the power of 6 because there are 1,000,000 zeros in total, and we have 1,000,000 minus 5 total possible positions. Right? When we say move to the next position, we are going to move for almost that many times. So we have 1,000,000 minus 5 possible positions. And in each position, we're going to have 2 comparisons. And I think you might also be interested in looking at question 21 during your free time, because I think it's used in last week's weekly quiz. Though we don't have enough time to go through it during the tutorial, but the main idea is that we're using brute force, generating all the possibilities, and then just keep track of the best solution.